just to introduce Professor Tsivanidis, who is going to talk to us about spatial methods and models. Thanks, everyone.
Great. It's not too loud, is it? My voice is like booming here, but okay, it's a pleasure to be here and to talk to you today about spatial methods and models. Vicky told me that a few of you are a bit apprehensive about the technicality of the session, but I can assure you that's not my aim. We're not going to get bogged in on details. We're going to get focusing more on understanding the intuition and how just the basic mechanics and intuition of how some of these models work. And then we're going to mainly talk about applications. So you can learn a little bit about what kind of doors these kind of methods can open for you in your own research. Okay, so as motivation, as kind of all of us in the room probably agree with by the fact that we're here, we know that cities are engines of economic growth, and they're a key destination of a lot of government expenditure and a lot of policy focus. Right, so you can think about the amount of dollars that go towards transport infrastructure, but also other forms of policy like housing and land use, crime and sanitation, and so on. And the kind of starting point for these kind of spatial models is going to be to recognize that the impacts of these policies within cities can be complex to understand and challenging for empirical work. Okay, so they can be challenging for empirical work because in cities you have a lot of linkages between spatial units. Okay, and that can create spillovers, and that can create a challenge for your typical analysis, right? So let's think of one example, a transport policy. Okay, and let's suppose that this transport policy leads to a new shopping mall being built, at the end of one of these lines. And so that shopping mall may affect employment opportunities and land prices and a range of economic outcomes for people who live even a kilometer away, who don't even use the new transit system themselves, but maybe they now, they work in one of these stores in the shopping mall. Okay, and so what does this mean for our empirical analysis? Well, it means that if we would typically if we wanted to measure the effect of this transport policy, maybe we'd want to look at outcomes for people who live within 500 meters of one of these new stations and compare how they changed with people who live further away. And the reason why these kind of spillovers can create a challenge is that the people who live further away can also be impacted by the policy. And once you think about this a little bit more, you realize that actually the entire city can be affected by one policy. And so it becomes very hard to have a pure treatment and a pure control. So that's a challenge for typical analysis that these sorts of frameworks are going to address, as I'll discuss. And then when we want to think about what the effects of these policies might be, they can also have indirect effects, again, because of these spatial linkages. Okay, so let's imagine there's a policy or just an underlying process of gentrification in one area. That then causes some people who live there, who can no longer afford to live there, to move to some other location. Right? So now this process of gentrification has affected not only the directly treated place, but it's also indirectly affected some other place where these people are going to. And it could push up house prices there. It could have economic impacts there. Okay, and so these, we kind of want something that can, we want frameworks that can address these both empirically in the data to understand just what are the effects of policies, and then also to measure the impacts of them, how different people are affected. And there's also a desire from, I think, both practitioners but also academics to have tools that allow us to understand the aggregate effect of policies. Okay, and this could be useful for stuff like cost-benefit analysis. Right, if you're a policymaker and you're thinking about, do I build line A of a subway versus line B, you would ideally want a framework that allows you to measure what the effects of those two alternatives might be. Okay, so that's by way of motivation. So I'm kind of posing some challenges that are there and some things, some objectives that I think we'd like to address. And so why do I think spatial models can be useful for addressing these challenges and allowing us to answer these sorts of questions? Well, I think there's four main reasons. So first, models provide a framework to allow us to think about what we expect to happen from a policy. Okay, why might that be useful? Well, it can tell us what data we want to collect and what data we want to analyze, right? So if you're going to go and collect a survey before some infrastructure or planning program is introduced, you might want to know what outcomes you want to collect and look at. Or if you're planning to use admin data, you want to know what variables and what data sets you might want to request. These models can also help us quantify the big questions, right? So they can let us answer questions like, what was the increase in real incomes following a new transit system investment, right? Which is the stuff that we ultimately care about. How much new land value is created by a regeneration policy, or how different groups in society are affected by a policy. Okay, these are questions that you can't answer just by looking at data alone, right? By doing regression analysis, because those kind of approaches typically look at relative comparisons between different groups, right? So they can tell you relatively how did land values go up maybe near a new transit infrastructure versus far away, but they can't tell you about how much they went up overall in absolute level. These models can confront and handle these spatial linkages and these network effects in empirical work, right? So this has been made quite popular in these market access approaches that we're going to talk about in today's lecture. And those directly confront the kind of issues that I spoke about with these spillovers, with the example of the shopping mall and the job opportunities created by it. And then finally, the models also can let us answer these hypothetical questions, right? So what would the impacts be of building alternative transit systems, right? So if you're a government and you only have a fixed budget, where should you allocate those resources in order to maximize their impact? Or questions like, if a slum is redeveloped, how much should you compensate residents, right? And we're going to talk about some research along those lines today. So what are we going to talk about in today's class or lecture? So first, we're actually going to go over some of the building blocks of these models, and I want to help you build some intuition for how these models work by kind of talking in small groups through a couple of exercises. After we do that, I'm going to kind of give you a brief summary of some of my own research that has used these economic models to answer transport and housing questions. So we're going to look at two from outside Africa. So we're going to look at some research on BRT in Bogota in Colombia, and some slum redevelopment in Mumbai. And then I'm going to talk about a recent paper looking in Lagos at the interaction between public and private transit infrastructure. And then briefly talk about a new ongoing work looking at climate risk and informal settlements in Freetown in Sierra Leone. And then finally, I'm going to give a little shout out to some work that I've been doing with Vicky and other members of the city of Cape Town to try to package up these models that can seem a bit intimidating and a bit complicated in a way that's accessible for practitioners to use. I'm going to talk about them in more detail at the conference tomorrow. But hopefully that's going to be a way to actually make these things useful and not just make them sit on academics' laptops and not really get used in the real world. Okay, so that's the roadmap. And so let's begin by trying to walk you through some of the basic building blocks of how these spatial models work. Okay. So what are the ingredients into one of these spatial models? What do I mean by one of these spatial models? So we're going to start off by thinking of a city that has many locations. Okay, so in some urban models that you might see, people try to simplify how they think about the city, right? So you might think of a city that's just a line, like a monocentric city model. There's a CBD, that's where employment activity takes place, and then the rest of the city is just represented in a stylized way by how far away from that CBD you live. Okay, and that was the kind of previous generation of the way that these models. And I think a big reason why these simplifications were made was a lack of data, like very granular data within cities that would let you, not make those simplifications and confront the reality of what real cities look like, right? Real cities do not look like perfect monocentric or kind of simplified representations. They have employment all over the place. They have different groups of people living in lots of different places, and they have transit infrastructure that can look quite complex, like a network, right? So here I'm showing you an example from Bogota in Colombia. This is showing you each polygon is one of around 38,000 blocks in the city. And these lines are parts of the transit network. Okay, so that's the first part. We need to say, what is the city? The city is going to be a bunch of locations, which you can think of as polygons, and we're going to represent geography in that city by travel times. How long does it take me from any one location to reach every other place in the city? Okay, so that's our kind of basic kind of framework, and then we need to say who's going to be doing stuff within this model. Okay, so we're going to have residents, people who live in the city and work in the city, and they're going to choose where to live and work. When they choose where to live, what do people care about? So they're going to think about primarily three things, right? First is going to be the amenity of the place where they live, right? So you can think of this as things that make it either more or less nice to live somewhere, right? So things like, what are the views, access to parks, how safe is it, or how much crime is in the neighborhood, what are the access to schools, and so on. Then we're going to have house prices, obviously, which people dislike. People care about house prices, but you want to live somewhere where rents are cheaper, all else equal. And then they're also going to care about access to jobs. Okay, so just how accessible is that place? Okay, so that's what they're considering, that's what they value when they choose where to live. They also choose where to work. And so what do they value, what do they think about when they're choosing where to work? Well, they think, just pretty simply, they think about how much they're going to get paid if they work in a particular location, and then they care about the travel cost, right? So how costly is it for me to travel from where I live to where I work? Okay, so that's the first kind of block, right? We need to think about the people who live in the city, what they consider when they choose where to live and when they choose where to work. Then we have firms, right? Firms, they choose where to locate, and then once they've chosen where to locate in the city, they choose how much labor and how much commercial floor space they want to use. Right? So like think of a manufacturing firm might need to use a lot of commercial floor space. It needs a lot of space just to produce its output. A kind of smaller retail firm might need a lot less space. What do firms consider when they're choosing where to locate? Well, they think about access to workers, right? So if somewhere is very inaccessible, if it's at the periphery of the city with no kind of transit access bringing people into it, then it's going to be very hard for the firm to persuade people to come and work for it, right? So to get a given number of workers to come, say 100 workers, they're going to need to compensate them either through higher wages or they're going to have to pay their transport cost or something. But anyway, it's going to be more costly for firms to attract workers to locations that are inaccessible. Then firms also care about how costly land is to produce there, right? So what is the price of that commercial floor space in that location? And then they also care about the productivity of that place, right? So you might think of, these productivities and amenities you can kind of think of as everything other than, so for amenities it's kind of everything other than house prices or job access that people might value. And for firms, productivity, similarly, it's everything other than access to workers or the price of commercial floor space that firms might value, right? That might make a place more or less attractive for them to produce there. Right, so I've just written down two examples. If somewhere has very good highways near it, right, a firm might think that place is more productive, especially if they're engaging in trade, right? If it's a warehouse, or if you think of Walmart or a big box store, they often locate at the edge of cities where land is cheap and where you have good access to roads, so they can get products in and out very easily. You might also think about like special economic zones, right? They'll provide a set of kind of maybe tax incentives for firms to produce there, but they also provide a bunch of infrastructure and public goods, right? So reliable energy, that might make somewhere more attractive for firms to produce there. Okay, then we have developers who build floor space. And then finally, in these models, these productivities and amenities can be allowed to depend on people and firms' choices as well. Right? So there's a lot of literature in urban economics trying to establish the relationship between density of economic activity and employment and productivity. Right? So people think that density might make firms and workers more productive because they allow them to share inputs or share ideas easier. And so that might affect productivity. And then you can also likewise think of ways that the type of people who live in a neighborhood might also affect its amenity, right? So if we have richer people who live in a neighborhood, maybe they invest in kind of private security, and that then makes that neighborhood safer to live. Okay, so these are the basic building blocks, right, of what goes into these models. And then the key kind of thing to think about in these models is a notion of equilibrium, which is what we typically think of as a concept that determines what you're actually going to see in the real world given all of these ingredients, right? Here I'm just telling you who's in the model and what do they think about and how do they make choices about where to locate. We then need some concept to tell us, well, what's the city going to look like given all those ingredients? What are house prices going to be? What are wages going to be? Ultimately, what's the city going to look like? And so this concept that we use in urban economics is one of spatial equilibrium. And the idea, can be summarized either by saying that everyone is happy or really that they don't want to make a different choice. Okay, so what does that mean for these different actors? For residents, it means that you've chosen to live somewhere and you've chosen to work somewhere, and now given the price of housing in different places and given wages, you don't want to move. Okay, so you're happy given amenities, house prices, and wages. You're happy with your choice. You don't want to do something else. For firms, likewise, it means, given the prices and given wages, you're happy with the level of workers that you have. You don't want to hire or fire any workers. And for developers, it means you don't want to build any more at the current prices. Okay, so now I want to work through an example, or I want you to work through this in small groups to see if you understand the concept or if you have any questions, and we can kind of work through it. Okay, so this is like a very, very simple toy example. Right, so let's suppose we have two neighborhoods, and let's have one that has higher amenities. Okay, so let's say one is a beachside neighborhood, right? People like being close to the beach, so that's going to be a high amenity neighborhood. And then we'll have another neighborhood that's more inland, okay? That's going to have lower amenities relative to living by the beach. Okay, let's suppose that these two neighborhoods have the same population and the same house prices. For the moment, I want to just ignore firms and developers. So just suppose wages and floor space supplies are fixed. We can just ignore them. So really, I just want you to think about this, right? So you have two neighborhoods. One has higher amenities than the other. And I'm telling you that these neighborhoods have the same population and the same house prices. And so I have two questions for you. Can this be in equilibrium? And if not, what would change until this kind of model or this world is in spatial equilibrium? Okay, so take 2 minutes, form kind of small groups, and talk through it, and then I'm going to call on some of you to see what you think. Okay, I think let's start to see how we're doing. So I'm going to call on this group, guys. So what do you think?
Well, we have discussed on this issue, and we have said people will migrate from one city to another city. The people living in amenities with lower amenities will migrate towards the city with higher amenities. As a result, they create extra pressure on the existing amenities that has high amenity. And there is competition. The laws may come down, may decrease later on.
So what was the last part?
Sorry?
Could you just repeat the last part?
Extra people will go to the one with higher amenity.
Yep.
As a result, there are many laborers competing to each other.
Yep.
The wages may come down, may decrease.
Yep.
Then that's the situation.
Yep. Okay, very nice. So I want to focus on the first part. So you said it can't be an equilibrium, correct? Because if those neighborhoods have the same house prices, right, then one of them has higher amenities, so people would want to move to the higher amenity neighborhood, right? And so maybe there's another group. What about you guys there? So what will change, and at what point will it stop?
So we thought the same. People will move to the place with higher amenities. And when they move to the place with higher amenities, the prices there of those houses would go up. And then the prices from where they live would come down. And maybe there would be some fairness.
Perfect, exactly. Excellent. Okay. Right, you guys nailed it. So thanks. Give yourself a pat on the back. Very nice. Right, so that can't be an equilibrium, exactly as the first group said, right? So if those two places have the same house prices, we all agree that the beachside neighborhood is preferable. So people want to move there, right? So then we come to the second group. What's going to happen and what's going to kind of mitigate and control that process? It's house prices, exactly. So as people move into the beachside neighborhood, right? I've said that the floor space supplies are fixed, so like housing supply is fixed. If more people move to a place with a fixed supply of housing, the price of housing has to go up. And exactly as you said as well, in the neighborhood that they're leaving, the opposite is true, right? There's now less people there with the same amount of housing. The housing price goes down. And so this continues, as you can imagine the first step of that. Well, what happens? That first step reduces the attractiveness of the beachside neighborhood, right? Because now prices have gone up a little bit, and it's increased the attractiveness of the inland neighborhood because prices have fallen there a bit. And that process is just going to continue until the gap in house prices perfectly compensates people for the gap in amenities. Okay, and so what happens at the end? Well, in our beachside neighborhood, we have more people living there, but we have higher prices. In our low amenity neighborhood, we have less people living there, but lower house prices. And importantly, residents in each place get the same utility, right? Because they're free to move. So if everybody is the same, and if everybody's free to choose where they live, then they're going to always end up getting the same utility, right? If not, then somebody's going to move. Okay, so are there any questions about that? Yep, question?
Would there be external forces which would affect the equilibrium? So if celebrities were to buy and raise up prices, for example, or government intervention, something like that, how?
So we're going to actually, so let's hold the thought. We're going to continue to develop this. This isn't the only example, but yes, so this has been a very, very simple example to try to show you that people moving and house prices changing will be forces that, that determine, what the city looks like, right? So if something changes, like if suddenly amenities get more attractive in somewhere, people are going to move, house prices are going to change, and how do we think about what the ultimate effect is going to be? I would just think about it in these two steps, right? So suppose first everyone's happy with what they live, with their choices. First, there's something that changes, right? So it can be amenity here, but you could think about it being a government policy. You could think about it being celebrity coming in and buying up, or Donald Trump coming in and building a golf club or something, buying up property, that leads prices to rise. That's the direct effect. And then the indirect effect is going to be people changing their choices, house prices changing until, once again, people are happy with their choices. Right, Vicky told me not to put any equations in, but I'm going to put one, but there's only going to be words in it, right? So question mark whether this helps, but it kind of hopefully will give you a little framework to think about this process, right? So this notion of spatial equilibrium is that people have to be, have to have the same utility regardless of where they live, right? So in this example, it was the utility in location 1 has to equal the utility in location 2. This is a framework for you to think about policy in general, right? So if you have some other government investment that changes maybe employment opportunities in location 1, you can help. This can help you think about, well, what's that going to do to where people live, to property prices, right? And so in order to think about this a little more rigorously, we need to say what people care about, right? So what are the utility and determines utility in these different places. Here's a very simple example, right? If people like amenities, they like job access, but they dislike house prices, you might formulate it like that. So higher amenity, higher job access is going to increase utility. Higher house price is going to decrease utility. Right, so now we can think about your example. What happens if the government builds infrastructure that increases job access in location 1? Maybe it's like a public works program. They just directly provide a bunch of jobs in a neighborhood in the city. They did this in Addis, for example. There's a paper looking at using these kind of frameworks to look at the effects of that. Well, then, if the government just starts hiring people in a location, it's more attractive to live there, so utility in location 1 is going to go up. What's going to happen? Well, people will start to move there. House prices will go up in location 1. They'll start to go down in location 2, and that process is going to continue until this equality holds again. Okay? So now I want to think about another policy, right? Again, in groups. So let's now think about a transport innovation. So suppose there's a new transport infrastructure that reduces travel times across locations, right? So you can think of this as a BRT or a subway. And I want you to think about what the effects will be, right? And now you can be a little bit broader. So we don't anymore have to hold, employment fix or development fix. You can just try to think through all of those actors and how they might be affected by the policy, but again, using this notion of spatial equilibrium to think about what you would expect to see in the data. So let's take a couple of minutes and discuss in small groups. Okay, let's see what you thought. How you guys wanna take a shot?
This one? Or
Yeah, no, in the middle there. Sorry, I didn't make your life easier by picking someone in the middle.
Okay, well, I can say that we use the words but and if, and it depends on a lot.
Okay.
So I don't think we came to a definitive answer because it depends on where the transport infrastructure is, and it depends on people's preferences. But I think one thing like in the beginning we said is maybe, so if you really hate commuting, then you would be very happy because now your travel time would reduce. But
Yep.
if you value space or some other type of amenity that you don't have in the location that you are now, maybe you would move further because you could keep your commute constant, but optimize for some other parameters that you actually value more. And then we thought about it from firms. So it might be the case that now firms relocate because their access to workers has changed. It might be some types of firms that relocate, but not others. Like retail needs less space, so they might move to the CBD, but manufacturing has different parameters. So I guess in summary, it was a lot of, it depends on this and that.
No, it's great. Okay, so you've highlighted a lot of the right channels. You know, it's fun before I started teaching in a business school, I would give answers kind of like that, very academic, trying to like qualify a lot of things. MBA students hate that. They want a simple answer. They want you to tell, you know, an answer, and then you can get into the details afterwards. So I think it's also it's how I want you to, you know, how I want you to use these frameworks and kind of. You do want to give an answer first, and then from that kind of qualify. But in what you said, there were a lot of the mechanisms there that I think are right and that are driving what's happening, right? So what did I pick up there? People like the fact that there's shorter travel time, right? And it also makes some locations more attractive, right? So if there's places that are maybe more peripheral where you have larger kind of land plots, those become more attractive. So what else do we expect to see in the data? Yeah. So you've got some of the changes there, exactly right. And now I want you to think about like what would you expect to see?
I just thought about one now. So when in South Africa, when our government introduced the BRT in Soweto is the largest township in South Africa. Yes. So it led to violence because the taxi drivers, they were not happy in saying that the government is going to take away their customers. So for the longest time, there had to be how it was resolved is that the government had to sit down with the taxi association, have a route map and say, okay, this is what we intend to do. So in South Africa, some of the things you can't just introduce like that. You have to think of who are the parties that will be involved.
Yep. So absolutely, and that's a key part. We can talk more about that when we talk about one of the case studies in Bogota. They also had to do a lot of advocacy and engagement with the stakeholders who would lose, right? So for most policies, you have winners and losers, and they can be very well organized. They're kind of taxi driver associations. That's true. But again, let's think about like what would we what I want you to take from these models is like a simple way to think about what the direct effects of the policy might be in the data. What do you expect to see about where people are living, where people are working, what will happen to property prices, right? That's the main aim of these models. And then there can be a second layer of things that you might want to caveat it with, exactly as the first group was saying. Like it might depend on this, it might depend on that. But we kind of want a basic framework to say, okay, these are the fundamental forces that are changing when you build new infrastructure. This is how I expect it to change where people live, work, and what happens to property prices. And now let me caveat that by saying, well, actually, in this context, you know, it was happening close to an informal settlement, so things were a bit different. In this context, the incumbent kind of private minibus drivers were very well organized, so it faced a lot of resistance. Exactly, that can be spot on. But my aim of these frameworks is to give you a kind of a way to think about that first level before thinking about the second level. So what does anyone want to say? Did any of the groups speak about what they expect to happen to property prices and where people live and where people work in the city? And then I'm going to show you a case, and we're going to look in the data to see what actually happened in one example.
So in the initial model, there was a difference in prices in the two regions, right, when it's at equilibrium.
Yep.
Which, if there's this infrastructure, you don't expect that the difference in prices is so big. It will actually cause a convergence because you expect that someone living far from the amenities still feels like I can still access it. So there's less marginal utility from actually moving to the amenities. Yeah.
Well, okay, but let's actually go through it with that, and then I'm going to show you the answer. So I think you're onto something, but I'll maybe come back to the first group, right? So let's say that this infrastructure comes in, and now it makes. You said that people like having lower travel times, right? And you mentioned that in some locations it's going to be. It's going to really affect how attractive they are. So you suppose you have a peripheral location that you now build a BRT line with, like a more suburban location. And now the travel time goes from 90 minutes to the CBD down to 30 minutes, right? So let's think back of this equation, right? What do you expect to happen? House prices should go up, and what else should happen? Right, so fundamentally, just stare at this and say, what's happened? Let's suppose location 1 is this suburban location. What's happened here, right? Job access has gone up because now it's quicker, right? So now this was an equality before. Now this is an inequality, right? Now location 1 is more attractive than location 2, right? So what do we expect to happen then? Think of that beach example, right? What happened when the beachside neighborhood had a higher amenity than the other one?
Prices adjusted. So yeah, the house prices in location 1 would go up and potentially relatively, or house prices in location 2 would go down.
And why did house prices go up in that example?
In this example, because job access increased.
Yeah. But what in our first example, in the beachside example, what was it that drove house prices up?
Amenities.
Amenities, but what change in the was there a movement that actually that changed house prices, right? People, exactly,
yeah.
Right? So in that model, we had this beachside community which had higher amenity than some inland place. And we said, okay, if they have the same house prices, can't be an equilibrium because in location 1, it was more attractive than location 2. People move to location 1, same amount of housing, prices go up. Exactly. So you're exactly right, but I just want to think about the full flow of how economic activity can change. So exactly. So in this example, what's going to happen? If we have a suburban place where access to jobs increases, people are going to move there, and then house prices are going to rise, right? And they may rise because of speculation in the real world, but ultimately, why would prices go up? Because the developers or the speculators think at some point, that place is more valuable, so people will be willing to pay more for it. More people are going to want to live there. Exactly, right? So let's go back to this example. You have new infrastructure that's built. What do we expect to see? Well, some places become more attractive, right? These are suburban locations in our example where travel times have decreased a lot. People and businesses may want to locate in places where accessibility rises, right? So we've been talking about this accessibility to jobs for workers, but you can also think about the same for firms, right? So I gave an example when we were talking about why accessibility matters for firms. Consider, suppose in Cape Town, there's somewhere very far away from the city center where the government's trying to induce firms to move. Suppose they're giving them a subsidy to move there. The firms don't want to go there with the current infrastructure because it would be too hard to persuade workers to travel maybe 2 hours a day to get there. But if you build a highway or you build a BRT and you make it easier for people to get there, then maybe firms now find it more attractive to locate in those places. And you see that in the data. Many cases of the building highways or infrastructure and firms also moving to those places as well as workers. Right, so that's our first, I wanted you to use these models to just have a conceptual framework in your head to think about first the direct effect, right? So suppose that you have an initial world where everyone's happy, everything's in equilibrium. Then you have a change, right? That's our transport innovation. Now I want to think about the direct effect, right? So what's happening? Now it's out of equilibrium because some places are more attractive. And now the second stage, which are going to be these indirect effects, is going to be that people move, firms move, prices change, right? So what's going to happen? After these places become more attractive, people and firms respond to that, so they start to move across space. Now the markets are out of equilibrium, so the current prices for properties, then supply is no longer going to equal demand, right? If everything was in equilibrium before, now more people are moving to some locations, exactly as the first group was saying, and now there's too much demand for the housing at the current prices, and prices are going to start to go up. Okay, and then prices are ultimately going to be the things that equilibrate. Think of it in these stages. You have a change that's a direct effect on the utility of living in different places. Then choices change. So people start moving in response to those differences in utilities. And then prices start to change. And the prices and the choices are going to be these things that kind of end up equilibrating till once again the payoffs are the same in different places. Okay, so now we're going to kind of get into some research and show you some examples of these sorts of models in the real world. But let's take a second to see if we have any questions about the kind of core concept of what's going on here.
So just one question. Can such policy lead to co-location of firms to one part of the city, was co-location of workers another part?
Perfect. So yeah, I'm not even going to answer the question because I'm going to show you some maps that shows you have very good intuition. The answer is yes, but let me wait till I get to the case study. Any other? Yeah, Christoph.
Right. My question would be about the role of kind of agglomeration efficiency gains from the firms, and how these kind of wage effects would have to be traded off there, and then also on kind of non-negotiable disamenities related to like criminality and the like, and how that could kind of short circuit this process.
Yeah. So I mean, they're all. So first of all of these things can be there, but I'll like from experience, if you begin by considering everything that can possibly happen, you'll never get anywhere, right? You'll be back in this world of like, well, this could happen, but that could happen, but this could happen, and you kind of, I don't think it's as helpful to think in that kind of way. I think what's really helpful is to have one, like, to think of it in layers, right? To have like, first, let me have a basic framework, and I can think about the fundamental force of what's happening, and then we can start to caveat stuff. And so to answer your question, how would you caveat it? They're just additional feedback mechanisms, right? So these models can all accommodate things like productivity being also determined by economic activities. That would be that feedback effect. Amenities can also be affected by it, right? So maybe there's a direct disamenity of transport infrastructure, like near bus stations, that could increase crime, right? You can accommodate this as well. But I would just think of this all as a kind of feedback mechanism, right? So the direct effect is that job access increases, right? And then people move there. Then maybe as a result of people moving there, firms can attract more productive workers, and maybe as a result of that, they can also make investments that make them more productive. That further increases job access. How do I expect the predictions of that model to be different? Well, I expect ultimately even more people to start moving to those places, and I expect house prices to go up even more. Right, but you can still, I would still, so here I've shown you how you can take this basically one equation with really three variables. We can think about it in a very simple way, and then we can say, well, now I've thought about this like first layer, what if locations also affect productivity? Well, you can just, continue to think about how it affects this equation. What if they also affect amenities? You can continue to think about how it affects that equation. Great question. Yep.
Okay, thank you. How is it sometimes it may not be possible for firms to move to the desired place because it might be structurally determined to locate in a certain zone?
Yep.
Specifically for residents and firms, these firms as well.
Yep. So you can have different variants of these models that can accommodate different degree. You can have exactly at one extreme, firms are completely fixed. Even you can make it even simpler. There's one firm in every place, and every place has a different productivity, and those firms can't move. You can have another extreme where you have firms that are moving across. So one answer is you can have different models that, based on what you think the context is, or even better, what the data is telling you, right? So like if you have a real policy change and you see firms moving, which actually is kind of a little bit unlikely, right? So I think what tends to happen in the data is firms the relevant margin for firm is where you set up shop. It's very rare to see like an actual establishment move to a different location. Often you see, they'll open a different establishment in another location. But one thing that's attractive about these models is some of them can be simplified such that even if you have different assumptions on, for example, firms moving, or do firms use capital or not, they actually look the same mathematically in these, and the same model can be used to handle both cases. And I'll talk about that when we talk about the first case. Okay, any other questions? Then we should get on so I can tell you about the applications.
Just a comment. What you're talking about happened in Gauteng when they introduced Gautrain, which is a train that goes under. So we saw that most near the stations, new firms started coming, insurance firm, and now they are about to extend it to go to another province. Currently, it's only in the Gauteng province from Pretoria and Johannesburg. But now, because of that, there are people who are even thinking of business opportunities. So what you're saying is currently happening in South Africa.
Great. So maybe you should write a paper on it, because tomorrow I'm presenting on the IGC spatial model, and I have some examples of countries, not in just the US or Europe, where these models have been validated, and South Africa is not on that list. But maybe you should write the paper, because I know there's definitely the data to look at it from some conversations I was having yesterday. Okay, so I have 20 minutes left. I want to now, hopefully I've taught you a bit about the concept of the way that these models work, and I'm happy to talk more about it afterwards if it's still unclear. But now I want to show you some applications, right? So we can go a little bit away from this dry kind of theory and talk about some real world policy. Okay, so I'm going to talk probably about 3 projects and maybe just give you a taste of the fourth. So the first is on bus rapid transit in Bogota and Colombia. So the motivation for this project was kind of not only understanding what are the aggregate effects of bus rapid transit, which many of you Cape Townians are familiar with through the My City, but also the distribution of the impacts across the rich and poor. Okay, and so what was the motivation for this? If you look in the data, as many of you will know, the poor really disproportionately rely on public transport. Okay, so this is data from Colombia at the mid-1990s, before this intervention came in. If you look at the poorest group of residents in Bogota, the vast majority of them are using the bus, and as you go up to the richest, they start to travel via car. All right, so that immediately, a plot like that just tells you that, well, look, if you see the rich and poor using different modes of transport, and then you improve one mode of transport, like public transport, then I might expect that to be a kind of pro-poor policy. And so, lots of policymakers care about redistribution and inequality, so that was kind of the objective of what I wanted to study. Okay, so this project was kind of focusing on a lot of these channels that we've been speaking about that are kind of stressed by these spatial economic models, right? So as the first group said, new transport doesn't only save me time, but it also changes how attractive it is to live and work in different places, and for firms as well, how attractive it is to live in different places. Okay, so now let me show you the answer to your question, as I promised. So here's a map of Bogota. Here is the BRT system, which is in black. And here what I'm showing you is a heat map of how firms' access to workers changed as a result of this network being built. Okay, so the red areas are places where firms' access to workers increased a lot, relative to the blue areas where it increased a little bit. Okay, so what is this telling us? So in Bogota, the highest density of jobs there's basically 2 CBDs in Bogota. One is in a historic center here, and one is a kind of newer center up here. And the highest density of workers is in the suburbs. Okay, and so what this map is showing you is that in a hub and spoke network, especially when you have a higher density of workers at the edge of the city, it's places in the center of that hub that see their access to workers increase the most, precisely because now they can access workers who are traveling in on all of these spokes of the network. Okay, so that's how this particular infrastructure was changing firms' access to workers. How did it change workers' access to jobs, right? Is this just the same map? Well, no, it's basically the opposite map. And when you think about it, it's kind of intuitive, right? So if I'm telling you that the highest density of jobs in Bogota are in these two CBDs in the center of the city, well, suppose I already live in the center of the city, right? Suppose suppose you're here in Cape Town, you live in the CBD, and a big new transport infrastructure is built. Well, probably you're already walking to work. Right, so it doesn't actually change your access to jobs that much if you build this big transport network, because you're already close to all of these jobs. What happens if you live here in the periphery of the city? Well, now really has a big impact, right? So Bogotanos who were living in the edge of the city were taking 1.5 to 2 hours to travel in to the CBD, mainly via kind of private minibuses that were congesting the roads and kind of driving dangerously and stopping all the time. Now you build this BRT and it cut travel times down to 40 minutes or so, right? So it's these places where you're really seeing an increased access to jobs in these central areas. Okay, and then I can look in the data, and I'm going to show you in a second that all of these channels that we've been talking about, right? So in that hypothetical example we just went through, we arrived at this kind of chain of events where transport infrastructure is built. That makes some places more attractive. Then people's choices of where to live and work change. Then house prices change. And that continues until everyone's happy again. This is exactly what I found in the data in Bogota. Okay, and I'm going to show you this in a second. Now, the value of travel time saved is an approach that's used often by practitioners to value the effects of new infrastructure. So it would say, kind of as you were saying, like people benefit from lower travel times. So if I want to think about what are the effects of what are the benefits of new infrastructure, I can just add up all the travel time that's saved, and I can just value that by people's value of time. Okay, and in the data, you see that the poor do use public transport more to begin with. So when you improve public transport, they save more minutes, and that approach kind of implies that they benefit the most. But once I account for these kind of equilibrium effects, you find that the effects are actually mildly pro-rich. So it's basically not that much of a policy for addressing distributional concerns, at least in this context. Why did this happen? Well, the effect on house prices and wages hurt the poor more than it did the rich. And it also was determined by how easy it was for the rich and poor to switch home and work locations, right? So you can think of how, actually, let me say, so the demand elasticity can affect the incidence of attacks. So if you think about who bears the cost of attacks on cigarettes, for example, which is a very inelastic good, well, it's going to be mostly smokers because they're not going to change their behavior, so they're going to end up actually paying the tax. You can imagine a very substitutable good like salt, right? If there's a tax on salt from the Himalayas, well, people are just going to substitute to different types of salt. So they're not going to actually end up bearing the incidence of that tax. And there's a very similar intuition that comes out of these models where the ease of which people can choose where to live and where to work depends on how much of the incidence of slow travel cost falls upon them. Yeah.
Sorry if I missed it. What colors on the map? Is that the conversation?
So colors on the map are how access to workers for firms and how access to jobs for residents are changing. Right, so this isn't actually showing you things that are changing in the data. This is a nice segue actually. So this is showing you what these spatial models say are changing for the attractiveness of these locations, right? So again, in our chain of events, policy comes in, changes attractiveness, choices change, house prices change. This is just showing you that first part of how the attractiveness changes. I can go to the actual data and show you how that change in attractiveness actually changes things in the data, right? So the model tells me that there should be a linear relationship between outcomes that residents care about, like residential house prices, and changes in this access to jobs, right? This map here. Right, so what was nice in this context is I didn't just have to simulate or hypothesize over what these effects would be. I could just look in the data and see what was happening, and that relationship was confirmed by the data. So here I'm showing you changes in residents' access to jobs that comes from the model, but on the y-axis this is change in residential house prices, and this just comes from the data, right? And so that linear relationship that's predicted by this spatial model is exactly what you see in the data. Okay, so that's for workers, but you can do exactly the same for firms. So here I'm looking at that other measure, how the change in firms' access to workers changes employment. And there you can see it's a bit noisier because of some of the data, but you see the same pattern. So places where in the center of the city, where this new transit network increased firms' access to workers, you saw a lot of establishment growth compared to places where it didn't change. Okay. Any other questions? Yeah. Did the model come from the accessibility index? Yeah. So the model delivers the accessibility index. So you start up with a model where people are choosing, exactly as I discussed, like kind of went over in the first part, people are choosing where to live and work. From that model, you get this accessibility index. You can measure that accessibility index if you have data on where people live and where people work, and how much you predict that the travel times are going to change as a result of new infrastructure. And so that's what I'm showing you here. So it's not that the accessibility index goes into the model. You're actually using a model to get your accessibility index. And it's then it's easy to measure that in the data. So if you were to do that in South Africa, for example, I know that you have all of the data here to do that. Right, which is why you should write a paper on the rail in Gauteng. Okay, I have less than 10 minutes, right? Okay, so I'm going to skip the second case, and I'm going to tell you about some research I did in Lagos, since that may be relevant to us here. Okay, so that first project was about what's the impact of new public transit infrastructure, but it kind of ignored actually this private sector, exactly as you were talking about. So this second paper is going to look at actually the same question. So here we have the government of Lagos, which undertook this bus reform initiative, which consisted of opening up 40 new routes with 820 buses over a 4-year period, which is roughly the size of San Francisco's bus system, but just being jump-started in a couple of years. But it's doing this in a context where that sort of investment is just completely dwarfed by the existing private network, right? So we collected data on the private bus network, so both where the routes are as well as the quantity of vehicles and so on. And the private network in Lagos has almost 800 private routes and 75,000 minibuses. Okay, so that's huge. It's 10 times the number of buses in New York's bus system, or 10 times the number of subway cars in its subway system. Okay, so what do I want to tell you about this? I want to quickly tell you what we did, and I want to show you what I think is a quite innovative way of measuring the value of time in a context where people don't have smartphones. Okay, so I'll go over very quickly what we did and what we found, and then I'll show you what we did to measure how people value time. Okay, so our question then was, well, in a world where you're making this big public investment, but you're doing it where transport is already provided by the private sector, how does the private sector respond? And how does that matter for how we should think about measuring the effects of measuring the returns on these investments? So first we had to collect a bunch of data during the rollout of a subset of these new bus routes. And so to measure what was going on, to look at the public system was kind of fine. We could use swipe card metadata, so we could see what was happening on the public system. But in the private system, we're completely blind to it, right? So that by nature of being informal, there's no administrative data that exists that can tell us about it. So we had to collect a bunch of our own data. We mapped out every route in Lagos, and we were able to measure the prices, the departures, the bus queues on all of these routes at one point in time. And then we followed some routes and some drivers over time so we could measure how outcomes changed as these new public routes were opening. Okay, so we were able to do a route observation survey where we measured prices and departures and queue lengths on around 280 routes over time. And then we also followed a panel of 850 drivers across 5 survey rounds. And so we could measure how their income, how their number of trips, and how their route choices were affected by changing over time as the new public system rolled out. So with time, let me actually just tell you what we found. So we kind of distinguished here between routes where the government entered and then routes that were connected to it, right? So you can imagine the government entering on a route going from A to B. A route from A to C may also be affected, right? So drivers may switch onto that route, or that route may become a feeder route, so people want to use the new public system, so they start using other private routes that are connected to these new public routes. So what did we find? So on the treated routes where these private minibuses face competition from the new government service, demand for minibuses fell. And so that meant that these buses now filled more slowly, but because the buses wait until they're full before they depart, that meant that the slower rate of filling meant that departure rates fell. And so wait times for people who continue to use the private system, they rose, right? As departures become less frequent, people have to wait longer, right? Two buses every half an hour means you have to wait 15 minutes. 3 buses would be 10 minutes. Okay, and we find that prices fall. But we also find things moving on connected routes. So we find that drivers, now they have less profits on a route where they now compete with the government service. And so they then change to other routes that are connected to those routes. And this substitution steals business from drivers on these connected routes. So now, if you're on a connected route, the government doesn't compete directly with you, but you are indirectly affected by the policy because these drivers are substituting into your route away from other routes where they face higher competition from the public service. And that leads to longer queues of buses. And that means that drivers who are on those routes now can complete less trips every day. And we also find that prices fall on those routes due to a greater supply of buses. Okay, so we then use a model to quantify how much drivers and commuters are affected by this policy. So I think this kind of gets to your question. So we wanted to measure, public investments in transport often face opposition from private unions or associations. And so we wanted to use this model we wanted to use the data and a model to try to quantify that. So in this context, how much did drivers lose relative to how much commuters gained? And we found that the losses to drivers were about half of the gains to commuters. So overall, this was a net positive, but it had very large negative impacts on drivers. But in order to do that, right, let's think of, if we want to measure how commuters are affected, we think that primarily when commuters are taking transport, they care about price and time. Okay, so in our data, we're seeing both price and time change. So prices we just observe directly, and then we see these departure rates falling, which means that wait times are rising. So it's kind of unclear how people are affected here. On the one hand, people who continue to use the private system, they like the fact that prices have fallen, but they dislike the fact that wait times have risen. And so we needed a way to measure how people value price and how people value time. Okay, and so we did this by developing an app that would work on basic phones. So this is a context where not everyone has a smartphone. So we wanted something that would work just on a basic phone that you could interact with through text. And we developed this app that I'll show you, and it worked as follows. So we recruited around 650 people who lived near a random sample of private bus stops. And we invited them to check in with us at bus stops over the next, at their bus stop. So this is the bus stop they regularly use for their travel over the next 3 to 5 weeks to participate in the following game. Okay, so here in the yellow hat is one of our enumerators. She has the LM for Lagos Mobility Study, and she has a smartphone. And this is the participant. She arrives at 7:11 a.m. And on the enumerator's smartphone, there's a code displayed. Okay? This code changes every minute of the day. So when we go to 7:12, there's a different code displayed. Why do we have this? Well, the participant who arrives, she sees this code displayed at 7:12 a.m. and she texts this to a number that we've set up, 3661. We receive this text, and because she's texting this number, and this number changes every minute of the day, we can verify exactly what time she's checked in, right? So we know she sent us this text, and we can send her back a message saying, thanks for checking in at 7:12 a.m. We sent her a fixed payment to compensate her for participating, and then we send her an offer back. So we say, we've sent you 200 naira, but if you wait 5 minutes more, I'm going to send you 400 additional naira. Okay? Then we continue to go on, the codes change. In this case, this participant decides that, look, okay, my 5 minutes are worth 400 naira, so I'm going to accept this offer. How do we verify that she accepts the offer? She has to text us the code that's displayed at least 5 minutes afterwards, right? So in this case, she waits for 6 minutes, she texts the code, we receive that, and then we verify that she's accepted the offer. So we tell her, based on that code, we know you waited 6 minutes, and we've sent you this reward of 400 naira. I know that I'm out of time, so I'm not going to tell you the rest of what we did. But you know, intuitively, whether the participants accept or reject these offers reveal their value of time, right? So in this example, because she accepted this offer, I know that she values her 5 minutes at 400 naira. But perhaps the next day, we randomize these offers, and the next day I offer her 100 naira to wait 30 minutes. She rejects that offer because her value of those 30 minutes is higher than 100 naira. Okay, so I'm going to end there because we're out of time. But I'll conclude by saying that transport and land use policies can have profound impacts on the structures of cities. Spatial models can be used both to guide empirical work that allows us to confront some of the challenges due to spillovers and networks, spatial linkages within cities, as well as provide laboratories to help us assess the trade-offs between different policies. And then hopefully that last case study gave you a little sample for how we as researchers can design approaches that can, you know, allow us to answer some of these questions in lower income settings. So I'll end there, but end with a little plug for the city spatial model, which was co-generated with the city of Cape Town, which I'm going to talk more about tomorrow, but this provides an accessible way for both researchers and practitioners to access and use these models. Thanks very much.
Great, thank you, Prof. Tsivanidis. Some chocolates for you as well. So what's the vote, everyone? Spatial models are still scary, or we've all got lots and lots of research ideas? Cities that work doesn't count.